Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
Hi students, in today's lecture I will be explaining about the chemical formula, how to arrive at the chemical formula based on cation and anion. Cations are anions are negatively charged, cations are positively charged ion. You have to remember like this. You know very well cathode is negatively charged electrode. So towards negatively charged electrode, positive ions will be moving, and that is why positive ions are called cations. Are you able to follow? Similarly, you got anode. Anode is positively charged electrode, positive electrode. So anions will be moving towards the anode. So negatively charged ions will be approaching positive electrode. So negative ions are called anions. So you must remember like this. Okay, right. Now let me try to give you various examples of these symbols and charges of monoatomic, diatomic, triatomic, polyatomic, cations and anions. Okay, and cations, as I already explained, they are positively charged and anions are negatively charged. Let us look at some examples of cation here. For instance, you have H plus, it is proton, but it's called a hydrogen ion. In fact, this type of H plus ions are available in acids, as in the case of hydrochloric acid, so H plus, and that is why it is called protonic acid also. So acid is the reagent that gives out H plus. Okay. Similarly, sulphuric acid means H2SO4. So H here represents proton, and this H has got the oxidation number +1 and its charge is plus. So hydrogen ion has got H plus. Then lithium ion, Li plus, lithium ion. Sodium ion, Na plus. Potassium ion, K plus. Rubidium ion, Rb plus. Cesium ion, Cs plus. Beryllium ion, beryllium cation, Be2 plus. Magnesium cation, Mg2 plus. Calcium, Ca2 plus. Strontium, Sr2 plus. Barium, Ba2 plus, and radium, Ra2 plus, right? And similarly, these ions can also be having a negative charge, as in this case of hydrogen. For example, hydrogen can have both positive and negative charge. When it is positive, it is H plus. When it is negative, it is H minus, and it should be called hydride. By convention, anions are named last and cations should be named first. For example, if it is a lithium hydride, lithium plus, Li plus, H minus, hydride, so LiH. Are you able to follow? So lithium hydride. Similarly, F minus, fluoride, Cl minus, chloride, and Br minus, bromide, iodide, I minus. All these are fluorine, chlorine, bromine, these are all iodine are called halogens, and the respective anions are called halides. Then oxide, O2 minus, it's called divalent anion. S2 minus, sulfide. In American English they use F, in British English we use PH instead of F for sulfur. Then selenide, you have to be consistent in fact. So selenide, Se2 minus. Telluride, Te2 minus. So these are all the important anions. And similarly, silver plus, Ag plus ion, nickel 2 plus ion, aluminium ion, aluminium 3 plus. This is trivalent cation. Similarly, we got trivalent anions like nitride, phosphide, then arsenide, N3 minus, P3 minus, and As3 minus. Okay, right. Now, we have this systematic nomenclature as well as common name also. For example, Cu plus it has got single plus. It should be called cuprous according to the old name, common name, cuprous. That is, lower oxidation states are having the suffix OUS. Higher oxidation state IC, cupric. In this case, Cu2 plus is cupric. But in the systematic name, we follow copper 1. That is, it should be indicated by the Roman letter. So copper 1, copper 2 means that is 2 plus. Similarly, ferrous, which is nothing but iron 2. Then iron 3, Fe3 plus means ferric, which is nothing but iron within bracket 3, Roman letter. And similarly, tin 2 plus, Sn2 plus, and it should be called by common name stannous. And the higher oxidation state is Sn4 plus, so stannic, that is tin 4. Similarly, chromium 2, chromium 3, and chromous and chromic. Then Mn2 plus manganese 2, manganous, Mn3 plus manganic, that is Mn3 oxidation state, manganese 3. And we have got the mercury. Mercury has got a specific unique name of that is mercurous and mercury. Here mercurous Hg2 2 plus, actually it is Hg plus only, mercurous ion mercury 1, but since it's the dimer, it is represented as Hg2 2 plus. But at the same time you have got Hg2 plus also, but that is not the dimer, that is mercuric ion, that is mercury 2. And similarly, so what do you call this Hg2 2 plus? That is called dimeric ion. Okay, so it has got the double form of what? Hg, that is Hg plus, it should be called Hg2 2 plus, that is nothing but mercury 1 only, that is mercurous ion. Then let me come back to the lead 2 plus, plumbous, lead 2, lead 4 means plumbic, then cobalt 2, cobaltous, cobalt 3, cobaltic, and similarly you have got aurous and auric. Aurous means that is with a single charge, that is gold 1. Gold 3 means auric. So all these names should be by heart. You have to memorize all this and better by heart all these prefixes and suffixes and charges, then names of cations and anions. Now sometimes you can have polyatomic cations and anions. Now we are looking at the polyatomic anions. NO3 minus means that is nitrate, it represents nitrate. Then what about nitrite? It is called NO2 minus. Then CrO4 2 minus is chromate. Then Cr2O7 2 minus is dichromate. And similarly we have cyanide Cn minus, permanganate MnO4. If it is manganate, it is a MnO4 2 minus. For example, when we have potassium permanganate, KMnO4. But when it is a manganate, it should be called potassium manganate, K2MnO4. So there is a difference between permanganate and manganate. Permanganate, the valency is minus, net oxidation state is minus, but for manganate it is minus 2. Okay, right. Then we have OH minus hydroxide anion and O2 2 minus peroxide anion. And similarly amide NH2 2 minus. Then we have got peroxide, as I already discussed, CO2 2 minus, then carbonate CO3 2 minus, and SO4 2 minus, that is sulfate anion. Okay. Then similarly we have oxalate, or that is derived from oxalic acid. It is the anion of oxalic acid, so C2O4 2 minus. And we have phosphate PO4 3 minus, phosphite is PO3 3 minus. Okay. Then we have got various halogen based, that is anions, like perchlorate ClO4 minus, chlorate ClO3 minus, chlorite ClO2 minus. ClO4 minus is called hypochlorite, ClO2 minus is called chlorite. Similarly we have periodate IO4 minus, then iodate IO3 minus, then IO minus, hypoiodite. And similarly we have bromate BrO3 minus, hypobromite BrO minus, then hydrogen carbonate, that it's also called bicarbonate that is HCO3 minus. And similarly, we have got hydrogen sulfate. As I already mentioned, for sulfur, you can either mention F or pH. So, sulfate, hydrogen sulfate, HSO4 minus. And whenever H is included, it can also be called bisulfate. And similarly, bisulfite or hydrogen sulfide, HSO3 minus. Okay, right. Now, we have got some more symbols like that is in the case of polyatomic anions or cations. In this case, we are discussing anions. S2O3, 2 minus, that is called thiosulfate. Then ASO4, 3 minus, arsenate. SeO4, 2 minus, selenate. SiO3, 2 minus, silicate. C4H4O6, 2 minus, tartrate, that is derived from tartaric acid. Okay. Then CH3COO minus, it is also written as C2H3O2 minus, that is called acetate. It is also by IUPAC called ethanoate. Then HS minus, hydrogen sulfide. BO3, 3 minus, borate. B4O7, 2 minus, tetraborate. And SiF6, 2 minus, hexafluorosilicate. SCN minus, thiocyanate. S is represented as thio here. So, thiocyanate. Okay. And there is one positive polyatomic ion called, that is ammonium. And this should be called, ammonia is NH3. NH4 plus is ammonium ion. Okay. And we should be aware of some the prefixes and suffixes also. Like mono means 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. For example, if it is copper sulfate pentahydrate, CuSO4 5H2O. So that hydrate, that is water molecules entrapped in the salt, that should be called along with the number of moles of water. So CuSO4 5H2O should be called copper sulfate pentahydrate. Are you able to follow? Right. Then, and we will try to obtain some names by combining that is some a proton and the anions. Thereby we are able to get some acids. And these acids can be classified into non-oxygen containing acid, then oxygen containing acid. Oxyacid, it can also be called oxyacid. For example, we have hydrofluoric acid, HF, HCl, that is hydrochloric acid, HBr, hydrobromic acid, HI, hydriodic acid, HCN, hydrocyanic acid, H2S, hydrosulfuric acid. If it is a gas, we can call it hydrogen sulfide. Similarly, if it is a gas, hydrogen chloride, hydrogen bromide. So all gases are called these gases are called hydrogen chloride, hydrogen bromide, then hydrogen sulfide. But when it is available as a solution form, it should be called the respective acid. Okay. So remember this. Then now let us proceed with nitric acid, HNO3. These are all oxyacids. HNO2, nitrous acid. H2SO4, sulfuric acid. As I already explained, sulfuric acid where F or pH can be used. Then, but you have to be consistent in one type of language only. Either you must use pH or F. Then, sulfurous acid, H2SO3. H2CO3, carbonic acid. Acetic acid, CH3COOH, and that can also be written as HC2C3O2. Okay. So these are the essential acids. Okay. Now let us work out some ionic compounds here. As I already mentioned, that is the groups of anion containing oxygen can be called ate, and their lower oxidation state can be called ite. Okay. And similarly, ide suffix, as in the case of nitrite, sulfide, bromide. Okay. Then ide in case of hydroxide and cyanide also. Right. Okay. Now we will try these nomenclatures. We will try to give the formula for this. For example, what is potassium bromide? We know potassium K plus. Bromide is Br minus. So K plus Br minus 1:1. The charges can be combined. Straight away you can put KBr. Got it? Right. And similarly, iron 2 chloride. So what is the oxidation state of iron here? 2. So Fe2, and here you have got Cl minus. So here 2 plus, here single minus of Cl. Okay. So in that case you have to nullify the charge. So multiply this Cl minus by 2. So 2Cl minus. So FeCl2. Are you able to follow? So likewise you have to practice, and you please go through all these things, and I'll be giving the entire detail about writing all these formula in my next video. And you can also try all these things. So you can try all these 25 molecules. If you are unable to do that, I will proceed with another video with how to write all these molecular formula based on our cations and anions. Okay, so thank you very much for watching this video.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.